today's changing world, one of the most important issues facing us is national security. In order to provide security today, technology, along with an unfortunate requirement for nuclear weapons, is required. A form of technology that plays a huge role in providing communications and intelligence is satellite communications. Satellite communication systems combine microwave, radio, and skywave propagation characteristics. These properties and its versatility make satellite communications desirable for the Ministry of Defence and National Security, enabling long-range, high-speed data and large coverage. Defence and security rely on satellite imagery as a fundamental source of information, offering knowledge of the territory, discrete surveillance and having frequent passes over any point on Earth. The Spot 5 satellite has the ability to obtain accurate, uniform geospatial reference data for headquarters and joint forces and quickly obtain a three-dimensional image of the terrain. The information can be utilised for threat evaluation, detection and location of the target, and assessment of damage to plan a relief operation. When deploying military forces to unknown areas of operation, 3D imagery provides territorial geospatial intelligence. The sharing of tactical data of 2.5 metre resolution colour imagery obtained from the Spot 5 can be achieved. Data can provide accurate geographic intelligence for military mapping and flight training and simulation. Within 24 hours of a crisis occurring, image data can be obtained in day or night and in all weather conditions through multi-sensor tasking capabilities.
The information can be used to correct aerial photography and provide imagery of an unknown area of land or water to understand the type of terrain and reconnaissance for future missions for things such as deployment of troops, landing of aircraft, or evaluating possible avenues of retreat.
The satellites are free to fly over the entire surface of the globe for observation, enabling the ability of reliable data giving precise information about areas of operations rapidly, repeatedly, and with discretion.
Some of the present issues facing us today when using the Spot 5 satellites are: whilst data can be obtained in a relatively short period of time, it is not suitable for time-critical situations where data may be required stat. Spatial accuracy at this time is still limited, and therefore we cannot use the imagery to obtain details of small weapons emplacements and infantry postings, or other small objects of importance. When operating in temperate or tropical climates, imagery acquisition can be delayed, distorted or completely obscured by undesirable weather conditions, such as cloud cover.
Spot 5 was launched on 4th of May 2002, improving on its predecessors by providing high-resolution geometric and high-resolution stereoscopic imagery. Spot 5 has a sun-synchronous orbit at an altitude of 822 km with an inclination of 98.7 degrees, providing a complete map in 26 days with 14 and 5/26 revolutions per day. A constellation of 3 satellites is in place, allowing 95% of the Earth to be imaged in any day. On board Spot 5 there are 2 main sensors utilised in defence applications. The first of these is the high-resolution geometric sensor. This is a 5-band sensor operating in panchromatic, green, red, near-infrared and shortwave infrared bands. The panchromatic sensor allows high-resolution data acquisition of up to 2.5 metre spatial resolution by capturing 2 offset 5 metre spatial resolution images. The green, red and near-infrared bands have a spatial resolution of 10 metres, whilst the shortwave infrared has a resolution of 20 metres. The main benefit of high-resolution geometric for defence purposes comes from the high spatial resolution in natural colour, allowing small targets to be seen and evaluated efficiently. The high-resolution stereoscopic sensor allows the production of digital elevation models by capturing images of the same area at plus and minus 20 degree offsets relative to the vertical. As these form a parallax view of the area, the images can be correlated to produce the digital elevation models. The panchromatic stereo pairs have a spatial resolution of 10 metres and are required using a plus or minus 20 degree viewing angle. During one pass of the area, the forward-looking telescope acquires the 20 degree angle ahead of the vertical, and 1 minute and 30 seconds later, the same area is viewed with the aft-looking telescope at an angle of 20 degrees. Because the radiometric parameters are identical, the autocorrelation process on board the satellite is made easier, and therefore the digital elevation models are of a higher quality and more accurate. The digital elevation models can be used to extract terrain parameters, acquire three-dimensional visualizations, create physical models, rectify aerial photography or satellite imagery, and perform terrain analysis. The constellation of two Pleiades satellites is due for launch in 2010 and 2011 and provides an evolution on the Spot satellite capabilities. The spatial resolution is improved upon the Spot 5 by lowering the pixel resolution to 50 cm from 2.5 meters across a 20 km by 20 km image. The increased resolution enables more reliably accurate data, allowing smaller objects to be viewed or larger objects in improved detail. Location accuracy is also improved from 10 meters to 3 meters. In addition, band spectral resolution within the visible spectrum is improved by providing a blue channel, which allows acquisition of more natural images. DEM acquisition is retained through stereo and tri-stereo imaging.